requirement. Say for example, if for a multi-story building, if you use by M40 or M50 grade concrete, it requires so much of thickness of column. When you go for a very high strength, more than 80 MPa concrete or 90 MPa concrete, drastically the column size will reduce. Column, it's not the size of the column reduces, it also saves a lot amount of natural materials. Second, also have some kind of materials which will improve the functionality as well as the resilience. There are some material which reduce the carbon emission. There are, if you ask in terms of cement, one is blended cement. Normally, as I mentioned in the morning, the individual house builders, at least they can contribute in terms of selection of proper usage of cement, like blended cement. The blended cement drastically reduces the greenhouse emission by more than 30% as compared to OPC cement. And whereas in those kind of construction, that much high strength cement is not even required. And what they use, if you go and see the site mix concrete, I mean with reference to in Indian condition I am saying, if you observe how they batch the concrete, the lady labor will be there who carries the aggregates, the mason who does the mixing, or the so-called it is the concrete operators, depends on their child. If the child is there, if she or he cries, one bundle of aggregate will be missing in one batch. Okay, and depends if he talks or smokes somewhere, that depends on his convenience. Half bucket of water goes there, in next batch full bucket of water goes there. Okay, it is actually, I have personally witnessed in one same site, every batch, you take that, we have been telling that you take a bondly, level the aggregates before you put it in the mixer. He says that I will put one shovel, that is enough. In second time, if he is feeling, if he has a tea or he smokes, he'll get more energized, he'll put two shovel in the thing. See, instead of level, it goes heap. Nobody cares. Okay, that is a level of quality of concrete what we are doing. And you see the amount of cement what they are using, per cubic meter they are using more than 7 to 8 bags of cement, which is not required. If you ask any ready mix player, he will not use more than 250 or 260 kg per cubic meter of kg of cement. Whereas what this guy is using more than 400 kg of cement, which is actually, if you use OPC also use the same kg of bags of cement. If you use PPC also use the same thing. That is what happening here. And then mostly the construction practices where there we have in India, particularly in the individual house segment, is very pathetic. And we have been talking about sustainability, various type of product, high strength, nothing is working out there. And if you try to teach them, he says that I have been there in this construction and I have been in the mason work for the last 40 years, don't come and teach me. This is what he says. And if you say that by using admixture, you can improve the workability, reduce the water content, and then it increases strength drastically. Those funda, it is not at all working there. Nothing. You go and see any site mix concrete, it's horrible concrete. So where there is that's what I am saying. If you are going to be a contractor, or you are going to be a promoter, or you are going to be a leading, going to play in some government agency, please carefully, ensure that this we need to control this kind of practice. I always, when I go for any engineers meet, I always tell them, at least before you go for completion of concrete for your site, go and observe what your masons are doing there. And it is not that you try to save the cost on cement by reducing the cement cost. Most of the site problems like cracks or seepages, bleeding, segregations are happening only because of poor construction practices. There are other ways that you use a highly reactive clinker or highly very high fine cement, which can drastically reduce the cement consumption per cubic meter of concrete. Also, there is another way of reducing the cement content is by designing the proper technique. So this one chart shows that how to reduce the binder content for the same strength of concrete. He has used various types of cement, and then he tried to plot the graph wherein says that for a given grade of concrete, you can reduce drastically the binder content. This chart shows that various types of cement he has used and try to plot the graph. Then if you see there, for a given grade, the binder intensity can be drastically reduced. The amount of binder what you are going to use in the per cubic meter of concrete can be reduced drastically. Yeah, see, as I mentioned, this is a standard concrete composition, around 70 to 80% the aggregates occupies. Remaining you have a cement. Then of course secondary cementitious material, you have a water and admixtures. Work out about these, let us not discuss about the admixture in there in the concrete with respect to Indian application. At least you can think of the this part where instead of OPC, if you try to use blended cement, which is primarily slag-based blended cement, which is having a clinker less than 40% in the cement, which will gives direct benefit on the environmental impact. And unfortunately, the code doesn't say that don't use this cement, it will lead to durability issues. But code also says that with respect to each application, you have to select the cement. But that is being ignorant. Nobody follows that in the site. And if you see here in this belt where this coastal, ideally we talk about chloride penetration is too much in the coastal, sulfate level is there, it will crack your concrete, reinforcement will corrode, but still OPC is being used. This is very unfortunate. You see, go there, this road, this highway, there is a one toll where this Padipatri place is there, where the toll gate, that complete concrete road is being constructed with the only OPC. Because the contractor is ready to use PPC or any blended based concrete. But our regulation says that no, you cannot use that. So what we are talking about durability, where is the durability is being addressed here? Yeah, how to reduce the cement contents? As he mentioned, adopt a proper design approach. One which is actually giving direct benefit is reduce the voids in the concrete, which can increase the concrete strength drastically. Also eliminates most of the concrete problems in terms of these cracks or durability issues. The cracks mainly comes from the cement contents goes up, the heat of hydration goes up, and it leads to cracks. That is the initial plastic shrinkage cracks. And the durability issues, how it comes, the sulfate attacks, when the ettringate is more, it leads to all sulfate related expansion issues. When the cement content is less, obviously the durability of concrete improves, whereas unfortunately the whatever the design practices what is there, it's going in the traditional way of nominal mix design. Nobody follows the design mix. So, he has done studies on changing the cement contents by various level of cement content and having two other cement. One is actually a high fine cement and also based on the silica fume based cement. And then this is the composition what he followed. Let's come to the conclusion here. See the compressive strength. With the cement content of just 111 kg per cubic meter, he could be able to achieve 71 MPa concrete with a high fineness cement. Whereas for the less fineness cement, the cement content is 260. With this, based on this, he has tried to study the carbonation, RCPT value, and then try to correlate with arrive the service life of the structure. See here, there is another approach which we can think of. There is most of the admixture companies are now working. Traditionally, the admixtures are being believed that it works on based on the two principles. One is electrostatic repulsion and steric entrance, which is based, this steric entrance is for polycarboxylate based admixtures. But there are new concepts which is actually believed that it will works on the cement particle surface. There is a new concept which comes there. There are admixtures which can also work with the other SEMs, that is supplementary cementitious materials. That will also covers and gives a more dispersion, which can reduce drastically the water content and improve the strength of concrete. This is one approach, new approach has been thought of. And you see here, just try to correlate, present these studies. The 260 cement content carbonation depth is just negligible range, whereas the 160 kg cement content shows the carbonation depth more, whereas the high fineness cement shows the carbonation level of around 1 mm. Why this 168 shows more, 162 kg is more than 268? Why it's more? The cement is same, but he used more water content. When you have more water content, then obviously a lot of porosity will be there. When the porosity level is more, the carbonation depth, it is carbonation depth. The carbonation depth shows more. Otherwise, actually, the carbonation is more related to the amount of calcium hydroxide which is there in the concrete. So, but whereas if you use the high strength cement, reactive clinker cement, it will drastically reduce the carbonation depth. And as he mentioned, the carbonate depth doesn't mean that it is going to affect your concrete. So I have come across one engineer there in Goa. He is actually chief engineer in Goa PWD. He is very stubborn on carbonation. The construction of two famous bridge which is happening there in Goa, they not allowing any other than OPC just because the traffic level is too much there. And just because of that, they don't want to use any blended cement because it increases the carbonation depth. Then I have to give a lot of reference of literature. Finally, he convinced for going for a concrete with more than 40% slag. Because in coastal, you have a more of humidity. And I have to tell him that when you have a concrete get carbonated, it fills the pores. When the pores get reduces, the carbonation depth will reduce drastically. That means it is not going to be impacting on your structural performance. As he mentioned, the pH is not going to come down below 9. It is just from 13 to it comes down to maximum 12. That's all. And then we have done some small study there in the laboratory to show and convince him that this pH is not reducing below 12. So this is what it is. Based on the carbonation depth, he tried to establish the service life of the structures. So one for various cement contents, there is the relation established based on the if you want to design the structure more than 70 years, what should be your reliability index if you use this amount of cement. So this is what the chart it shows, and say here for each type of cement, and for sustainability, you see here what is the impact on the global warming impact with the various type of various contents of cement and various type of cement. And what he says this is actually eye opener for us as a cement manufacturer. For a given limestone, what is the best process I can adopt to improve the clinker reactivity? If I improve the clinker reactivity, one way for cement manufacturer, you can absorb more amount of fly ash or GGBS in blended cement, or second, you give a cement which is very highly reactive cement. For a customer, say for example, precast customer, you can drastically reduce the cement content. Or you can go for a slender elements which are very high strength in nature. You can go for a more span structures. So these are all major advantages. But in India, we don't have any cement other than normally the C3S ranges from maximum 40 to 52 ranges. There are only one few companies like latest technology adopted companies having a C3S contents of more than 55. Otherwise, most of the cement company, what we produce here, it ranges from 48 to 52%, the C3S content. Yeah, the sustainable index is been arrived based on the compressive strength. That means usage of less amount of cement and improve the surface life of the structure, which has a less amount of global warming impact, and it improves the sustainability. This is one way of looking at the sustainability of structure. And to summarize, how to improve the service life of the structure, use the material which has less carbon emissions, like high reactive clinker, or usage of blended cement, usage of supplementary cementitious material, or less cement in the per cubic meter of concrete, or usage of high performance concrete like high strength concrete, where you can drastically reduce the cement content, or increase the or reduce the size of the column. Also use more amount of supplementary cementitious material. Proper design of concrete mix design using particle packing theory, which will give the direct benefit on saving of natural materials. Also use the more amount of industrial byproducts. I would not call it as an industrial waste, rather I would call it as an industrial byproducts. The most of the industrial byproducts like fly ash or GGBS are still is being not completely utilized. Still a lot of material is been dumped outside, and it creates environmental pollutions. In ACC, what we thought, in traditionally in some markets where the customers are not ready to use blended cement, where they prefer only OPC, we make effort to bring in a blended cement which gives a strength at par with the OPC in terms of grinding it very finer, adding the high, admixture which will improve the reactivity of the clinker. Third, you have a fly ash ground separately and add it to the cement, which will have a more volume of concrete. Ideally, as he said, if you replace 1 kg of cement with fly ash, which is having less specific gravity, you are having more than, if it is a 30% clinker you are replacing. Ideally, the volume, if you have equivalent volume, it will be more than 45% of fly ash should be there by volume weight replacement. So, with that concept, we try to promote high strength blended cement, which will meets the customer requirements there in the individual house building segment. Also, we try to bring in some new concept. Mostly in some markets, traditionally people have a concept as one way of looking at what he director has mentioned. I have constructed a red mud type of wall and then mangrove tiles and things like that. But if we go for that type of structure, where is the land available? You have to have, if you want to have a mangrove type of tile structure or mud structure, you have to have you cannot construct a building more than 1-story building with that type of material. You have to construct within the ground, where is the land available? And whatever the material what we have now, we have to utilize that more. So based on this, what we thought of, try to promote and bring in the entrepreneurship by promoting the sustainable construction practices for eliminating the clay bricks. The NGT, National Green Tribunal, has banned the mining of soil for making brick. So the scarcity of